Hello, good evening, all of us. Wait for few minutes, at least 5 to 10 minutes. All participants will join. Then I will introduce Mr. Vivek S. Okay, we'll wait for 5 to 10 minutes.
Madam, my voice is audible, madam. Hajira, madam.
Good evening, all participants.
Madam, good evening, madam.
Good evening, sir. Good evening, Vivek, sir.
My
Sir, your
voice is
audio
okay,
is
madam.
okay, sir. Do you want to play any video as well in your presentation?
No, madam. Only the PPT.
Okay, fine. Your
PPT is
audio is
visible,
good, sir.
yeah.
We'll just wait for a few more minutes. Once we have a maximum number of participants, we'll start off with the session.
Sure,
Thank
ma'am.
you.
Okay.
Hello, sir.
Hello, madam.
Yes. Okay. Thank you. Hello. Sorry. Yeah. Good evening, all. Today I'm introducing the Mr. Vivek S. And he has done BTech and MTech from JNTU Hyderabad, MBA from IIM Indore, currently working as a subdivisional engineer in BSNL, more than 20 years experience of field experience in BSNL, including training center, specialization in wireless communication, 4G, 5G, 6G, IoT, telecom network, MPLS, VPN, artificial intelligence, machine learning, and deep learning, NLP, and computer version. Deliver several talks, lectures for the various organizations, Indian Railways, BBNL, NITTR, NMDC, Universities of SCO, MANU, SRM, VIT, Manipal, Geetam, IT's companies, and engineering college, CBIT, VVR, VNR, Vardhaman, Sri Devi, MGIT. He is guiding the more than 4,500 students for the internship and project of 2019 to 2020 and received official appreciation for 3 years 2019 to 20 for the best performance. Sir, please start your lecture. Mr. Vivek, sir.
Thank you, madam. And once again, good evening, all the participants and all the faculty members of the Manu University. Uh, Today's the topic of this evening is green buildings and sustainable architecture. Uh, in this presentation, we will discuss the various points of. We will discuss about the introduction to green buildings, the goals of the green buildings, the benefits, the fundamental principles of sustainable architecture, and what are the various green certifications that are there internationally, globally, as well as Indian context. We'll see some case study. There are several case studies are there. One case study which where green buildings and sustainable architecture is implemented, and what are the challenges that are present, the future trends, as well as the global perspectives on sustainability, which is very most relevant topic in the present day time. I will conclude with the other possibilities that are there in this area. So firstly, what is this green building? So everybody, this is commonly understand what is this green building. Mainly, the green building, a purpose is to design the building in such a way that it reduces the environmental impact. So the green buildings are also we can call it them as sustainable buildings. So the structures, civil structures which are designed and built with environmental responsibility, they are called as the green buildings. Environmental responsibility means we also have to think about the resource utilization. The resource utilization also should be efficient and should be minimal, and the various characteristics of this sustainability lies in environmental responsibility, the material responsibility, resource responsibility, energy responsibility, water conservation, health maintenance, and then even the air quality maintenance. So all aspects, the green buildings looks at the environmental sustainability in the 360 degrees perspective. So we can say that the aim of these green buildings is basically to reduce the overall impact of the pollution, or the overall impact of the over utilization resources on human health, and also on the natural environment on the globe throughout the life cycle of those buildings. Throughout the life cycle means starting from the design of the building, and then architecture of the building, and then implementation or execution of the building, and then maintenance of the building. And also maybe at 20 years down the line, 50 years down the line, and if you are planning for recycling or demolition of the building, there also are destruction of the building. So right from the design to construction, operation and maintenance, renovation of any in future, or destruction, or deconstruction, or destruction of the building, in any all these life cycle, the impact on the human health and impact on the natural environment should be as minimal as possible. That is a basic idea behind the green buildings. So you can say that the overall idea, the overall goal is to give the our current environment in a better way, or in a best possible way, to our next generation. So this is the main idea. So as I told you, the green building not only involves design of the structure, the civil structure itself, but also about the process that are involved. So this is where our experience is involved, because we have we do the consultation for some organizations, basically government organizations, and mainly. So under this sector, for example, we recently had for the IIT Hyderabad, long back Manu also, and BSNL, they're trying to conserve the uh, environmental, to focus on the energy and efficiency and water conservation, and some of the practices they're following. We'll see down the line what are the other things we are doing. And focusing mainly focuses not only on environmental responsibility, but also resource efficiency is one more thing. And the other thing is the sustainability should be there. Whatever materials we use, whatever resources we use, whatever process we use, they should be responsible throughout the life cycle for the environment. That is most important thing. And basically it is also, as I told you, so even it builds upon the traditional building design considerations, like it should be economical, utility should be there, durability should be there, comfort should be there, and these the dimensions also are considered while designing the or while certifying the building as a green building. So traditional practices which are very efficient, which are environmental friendly, are also being considered. And what are actually the goals of the green building? The goals of the green building, as you told, they are, you can say, 5 Rs. What are these 5 Rs? So the starting with the reduce the usage of the materials, reduce the usage of the resources, reduce the usage of the site, or reduce the usage of the water, reduce the usage of the energy, reduce the usage of every possible thing that is involved in the design or construction, in the transportation of the materials also. Each and every point, and each and every criteria is there for certification of the guild building, and also for the purpose of environmental sustainability. So, and then reduce and response. What kind of response will be there? Response is important. Reduce in case of any issue, in case of any shortcomings, in case of any bottleneck. What response is or what action is taken in order to resolve that issue? So renewal of resources, because recycling, renewal are very, very important things. And refusal to accept anything which is against the environmental sustainability. So these are the primary goals. These 5 Rs are the primary goals of green building, which are, you can say, design philosophy, which are there as a design philosophy for going ahead for the green building. And what are the benefits of the green building? As not only environment sustainability, apart from the environmental sustainability, which is the main objective of the green building, the other benefits are economical. Even economical benefits are there. Even the capex effect will be there. Operational expenditure, even OPEX also. Both it has a lot impact on capex as well as OPEX, which are very vital metrics or financial metrics for any organization. It may be the government organization or a private establishment or any other firm. So reduce operational costs, as I told you, the OPEX. And apart from the OPEX and CAPEX, it has got the impact on the health of the occupants. Occupants may be the residents, it may be the offices, or it may be the people who are occupying those green buildings. It will be having very positive impact on them. And also the productivity through the better, it's productivity of the health of the occupants or health of the inmates of the green buildings are better if they are using less resources, and with a better comfort and better ventilation and better availability of the natural air. So obviously the productivity of the inmates, productivity of the residents also obviously improves. So, and finally, if you are caring about the environment, the climate change, it will combat the climate change. So by reducing the carbon footprint. So carbon footprints, so the consumption of the carbon footprint, carbon in our during this green building life cycle will be greatly reduced. So these are the benefits of the green buildings. So what are the principles of the sustainable architecture? So there are some fundamental principles of the sustainability. So whatever architecture you are going at, there are some fundamental principles. The focus of the sustainable architecture is basically minimizing the resource consumption. As much as possible, the resources, as I told you, from the site, materials, transportation, no, even the fuel, even the energy, water, and even the waste sewage, or whatever resource, whatever element that is involved, everything should be minimized. The consumption should be minimized. Even the waste also should be minimized. And you also have to ensure that the waste also recycled. And of course, the best examples are in our neighborhood. So many even nearby Serene County, which is there near to the Manu. So, or you can take the latest establishments like My Home or Sapanna. They are doing it, and also the CII building, which is there in our Gachibowli area, the Godrej Business Center, the Godrej Building Center, that is CII Confederation of Indian Industry building, that also is having a green building, or the My Home Bhuja or Aparna Cyber Zone or Commune buildings, and more Tripura constructions are there, and so many gated communities. Government is also ensuring. We'll see down the line what are the certifications that are there, what are the criteria that are there to ensure that environmental sustainable development will be there. And the approach for following these fundamental principles is to create the building that are environment responsible as well as resource efficient. These are the two criteria that are followed. And as I told you, what are the fundamental principles? Fundamental principles are of the sustainable environment is a sustainable architecture of the green buildings. So as I told you, these are the various uh, efficiency factors which are we can say which are the metrics, key metrics which are involved in sustainable architecture implementation. Structural efficiency, that is civil structure efficiency should be there. Energy efficiency, the power consumption should be as minimal as possible. So wherever it's possible, we'll also see that. Water efficiency, water conservation practices, the best practices. Material efficiency, the usage of the materials, construction materials, and then maintenance materials, and as well as the recycling materials, etc. And waste and toxic reduction as much as possible. These are the fundamental principles for sustainable architecture of the green buildings. Okay, and coming to the main thing. So you can see here, coming to the structural efficiency. If you take structural efficiency, it talks about on the impact on the cost and performance. Cost and performance means the total project cost, the project cost, because when you are talking about a structure, a civil structure, a building structure, the design efficiency, if you are if you are taking care of the best design efficiency, obviously there it will be having very good impact on the total project cost as well as the performance of the project. So that is so overall the objective of this also to reduce the overall minimize the total environmental impact and in every stage of the building project. That is the idea. So idea is, so during the kind of design, structure design, the best practices are to be followed to have better environmental impact. So for example, what practices we can make for a structure to improve the structural efficiency. So one of the things that we can do is we have to use as much as possible. The local ecosystem is to be involved as much as possible. So when for example, one of the important factor that will be involved in structural efficiency, the site selection and design. So while selecting the site, we need to see that how suppose when you are going for a big green buildings, when we are going for a sustainable architecture, we have to select the site in such a way that it is properly ventilated, it is properly environmental, the environmental disruption is as minimal as possible. For example, if you are having a lot of vegetation in that site which you have selected, and to construct the building, if you have to deforest all the plantation or all the landscape there, that will be having a negative effect, negative impact on the environment. So while selecting the site itself, you have to see that what the minimum expenditure is there. For example, not only expenditure, minimal environmental impact will be there. And for example, there are a lot. So there is a lot of when hillock is there in the site, or some uneven plane is there. So then that whatever unevenness is there in the surface, or whatever vegetation is there, that should be considered while designing it, so that the minimal impact will be there. So while designing, we have to integrate the available resource, the natural landscape or biodiversity. Maybe lakes are there, Besides our Manu Hyderabad, we also have Tourism Department. College is there, Nitim. And Nitim also, you see, you can say the biodiversity is preserved by maintaining the lake in such a fashion. The biodiversity, the lake or the ecosystem that is available, the flora and fauna that is available in that is pre-existing in that site, that should be preserved in order to integrate it in the design for the sustainable architecture. And the others, apart from the structural efficiency, another fundamental principle of energy conservation is the that is energy efficiency. Energy efficiency, you can say, it is a cornerstone. It is the very much pivotal. It will play a pivotal role in the green building design. Uh, so, as you know, this even the government of India has recognized this key role, and not only government of India, every government, most of the governments across the globe, we are finding that these people are focusing on it to reduce our reliance on fossil fuels and to have usage of non-renewable resources and you can say renewable resources, or you can say non-conventional energy resources like solar, usage of solar plants, usage of air turbines or wind turbines, or usage of desalination plants, or usage of hydel plants, etc. So there are several things that are in place just to improve the energy efficiency throughout the life cycle. So the purpose of this is to the lower power consumption. Not only it will have impact on the operational expenditure, but also it will be having huge impact on the efficiency of the project green building, but also on the environmental impact. So the one of the fundamental thing which I have told you is the renewable energy, or energy from the non-conventional sources. Non-conventional sources like the solar plants, wind turbines, geothermal systems, are now even government are looking for the hydrogen plants. The green hydrogen plants people are looking at. So these are the some of the areas where integration of these renewable energy sources, if you are integrating with the sustainable architecture, you will be having a lot of impact. So we have to see that in the green buildings, the renewable energy sources are integrated, are incorporated for sustainable buildings. This practice, as I told you, the reliance is to reduce the reliance, or to reduce our dependence on the fossil fuels like petrol, diesel, and then gasoline, etc., and which will reduce the carbon footprints, which you have already seen in the structural design also. Our aim is to reduce the carbon footprints, so it will lower the greenhouse gas emissions also. So greenhouse gas emissions also gets reduces, and it will have a positive impact on the environment. So it will help in reduction of the pollution. It will help in reduction of the over utilization of the resources, thereby helping the Mother Earth to have greater sustainability. And the other important aspect, which is the other important fundamental principle for sustainable architecture, is water conservation strategies. So water conservation strategies are very, very important. This is also almost all the green communities or green buildings. It may be the commercial establishments or the residential establishments, or any you can say partial private and partial public enterprise companies. So the water conservation is the most vital thing. So the water conservation techniques like the grey water recycling talks about the waste sewage water, or the waste water from the bathrooms, or waste water from the washrooms, waste water from the washing machines, or waste water from the kitchens, or the mess, or the canteens, etc. So these grey water recycling plays a pivotal role for reuse of the these grey water can be used in multiple purposes, for the landscaping or gardening. You can use it for the the purposes for the flushing in the washrooms. So the grey water can we keep on using it. We can use the same resource multiple number of times. Apart from it, the no there is no one is external water also harvesting is also most important. Rainwater harvesting, this is also something which is being implemented for a long period of time. It should be implemented not only by the government but also should be by the establishments in a more efficient manner, so that whatever rainwater that is there should be preserved and it should be harvested in such a fashion that that can be reused for a longer period of time, that can have the reduction of the burden on the bore wells or the groundwater, and it can try to no, increase the water table level. And also the other important thing is low flow fixtures. So low flow fixtures means in the bathrooms or in the washrooms, in the kitchens. One of the water conservation technique is the flow. Instead of using the fast flow of the water taps, the flow is controlled. The flow is regulated with the help of some fixtures, which will help in conservation of the water and reduce the water usage. That is also one of the important techniques. And apart from the green buildings will also, the sustainable architecture also talks about preserving the local water resources in the ecosystem. Water resources, just now we talked about the example of lithium, where the water lakes are there, that is preserved and it is preserved in the site without you can say grabbing it without encroaching it or without making a landfill on it. So this preservation of the water resources helps in raising the water table to the maximum level. And apart from the principles of energy efficiency and structural efficiency, the other important thing is about the material efficiency. The sustainable material efficiency you also have to take care. So whatever materials you are using for the construction of the building, green buildings or sustainable buildings, or for the usage of the furniture or the interiors or the for any other appliances we are using in the building, everything should be selected, everything should be designed in such a way that should be minimize the environmental impact, not only during the usage, not only during the operation, but also during the production itself, during the manufacturing or during the transportation. So come throughout the life cycle. So green buildings certifications also takes the criteria of each and everything throughout the life cycle. Throughout the life cycle means right from the production or the manufacturing of that material, or the transportation of the material, or the sourcing of the material. The sourcing of the material is to the suppose when you are constructing a building and we are getting sourcing, since we are getting a the cost of the material is less, we are procuring it from a far place, it will be having, it will consume more it is having more carbon footprints, because since we are transporting from a longer distance, because of the low cost, what will happen is it is having more environmental impact because of the logistics that are involved, because of the environmental impact, because of the greenhouse gases that the transportation vehicles are emitting, and all these things will be considered, and the credits will be calculated basing on that thing. So one of the important thing is even the local material. The importance of the local materials also is one of the key thing. Local materials, because if you select the local materials, the advantage is the transportation emissions will be reduced, and also it will support the local economy. So sustainability of local economy, local communities are very much considered in the green building, because the traditional practices should be considered in a greater way during the green building or sustainable architectures. And materials like bamboos for furnitures, for interiors, or for landscaping designs, and materials that are used. We can use materials like bamboos or reclaimed wood or recycled wood or construction waste. whatever construction waste that is available, and you can also use the construction waste or the steel which is recycled, or plastic which is recycled. They're often used in the green building. So if when the material, whatever material you're using, if they are already recycled material or already used material, or no, or the garbage that is there from that you are using it, it is having a lot of impact on the environment. Apart from it, the in the what is the other important point, and what is the other important fundamental principle of the sustainable architecture is the indoor environmental quality. So the materials that are used for the green building, they should be in such a way that the materials that are used means you will be using the interiors, furniture you will be using paints, you will be using you know, and lighting, you will be using so many materials which are toxic also. So one of the fundamental principle is we need to also monitor the occupants' health and well-being. So if suppose you're using a paints that are emitting a lot of chemicals and a lot of toxic gases, it will have a negative impact on the health, and it will be having no a negative effect on the sustainability of that uh, uh, occupant. So that is considered by no, factoring what is called as IEQ. IEQ stands for Indoor Environmental Quality. IEQ stands for Indoor Environmental Quality, which is also vital for the occupant, resident health or occupant health and well-being. So what is the most vital is, so while designing the building itself or while constructing, we have to see that the IQ should be there. So if you are considering a business, this is the building plan, you have to see that the IQ, so natural lighting should be there, good ventilation should be there, and non-toxic materials in case of even the cement quality, or in when the paints which are using, in when the furniture which you are using, in the materials which are using, or maybe the steel which you are using, everything should be taken into consideration during the design and the implementation stage. And also, of course, if you also prioritize not only the health but also the comfort and the health, obviously the productivity of the occupants will be increased. uh, and and the indoor environmental quality. So the idea is, as I told you, IEQ. So IEQ is having the what are the effects of maintaining IEQ in green building a sustainable architecture is the comfort level of the occupants will increase, the well-beingness will increase, the health will increase. Obviously, if you are maintaining the no your occupants of the buildings, maybe the employees or the staff or the faculty or the workers, and if their comfort level is increased and if their health is improved and if their the well-being is looked after, obviously the productivity will be much more improved. And the green building should ensure that the proper landscaping is there and proper ventilation is there and proper greenery is there, so people can stay healthy and not only say comfortable, but the whatever air they breathe will be clean. So that is the idea. Clean air should be given to the inmates. And also you have to, as I told you, whatever materials they are using should not be harmful to the health. uh, and also living and these the whatever no, the living comfort or working comfort that is in the building will be they should ensure that the inmates or the occupants or residents should not fall sick. So that is the idea, fundamental idea. And what else are the fundamental principles of the sustainable architecture? Is the one of the other thing is where our technocrats come into picture is the innovation and technology. So innovation and technology is also considered, and this is where a lot of advancements are happening. And while considering the sustainability, this is to be considered. So what are the new? So you have to abreast with the designers and the construction contractors and then the engineers. They have to be aware of the new technologies, and they also have to adapt creative ways of building these structures to help the environment. For example, the solar plants. So and you have to make space that on the all that terrace should have it should be installed with a solar plant. The terrace should be wherever possible that is there. It should be having a green landscape so that it will be having a positive impact on the temperature of the building, and should that the reliance on the air conditioning or HVACs which we use in the building, big buildings or office buildings or the academic buildings, that will be reduced. The reliance on the air conditioning equipment will be reduced. There will be power consumption will be there. There will be energy efficiency will be there. There will be the environment impact will be there, and also well-being of the occupant will be there. So advanced insulation methods. Advanced insulation method means whatever the coolness that is there in the building can be preserved with the help of insulation materials. What are the insulation materials which are used in the on the wall that are to be selected in such a way that the whatever coolness that is there, it will not be it will not be reduced, and also the heat also will not enter into the building. Depends upon the usage. And the green roofs. With green roofs, as I told you, green land and grass landscape can be done on the top of the building, whereby the temperature of the building comes down by 2 to 3 degrees, which is will be greatly impacting the coolness or the wellness of the building. And the other important things is permeable pavements. If you see permeable pavements or whatever footpaths we use currently, this is the current practice which we are making. This will help in no water conservation. So water conservation, whatever water conservation is natural water conservation, natural rainwater harvesting. You can say water that will be falling on that pavement can be preserved. And the other important thing in innovation and technology is the usage of smart building technologies that is coming up in a bigger way. And we can say this smart word is coming everywhere. Smart buildings, smart cities, smart campus, and then smart homes, smart colleges, smart universities, and the smart cars, and you can say smart, even the smart gadgets. So everywhere you can see the smart. The what is the prefix of smart building? The smart building or sustainable architecture. The smart prefix is also a vital thing, which is a adoption of technology in the green building architectures. What is the smartness means? Usage of the technology called as IoT technology, or usage of MMTC technology. What is this IoT means? Internet of Things. So which will greatly help in for a construction of the big building, even for homes also, even for apartments or gated communities. At least the smart building techniques are coming into picture, which will greatly improve not only one factor, multiple factors. It will help in energy efficiency mostly. So energy efficiency, it will help in the better cooling and better comfort to provide better comfort of the inmates, and also the resource optimization also will be done with the help of this, and also safety measures. So some of, for example, if you see, and a lot of comfort will be there, a lot of energy conservation will be there, a lot of you know uh, environmental impact will be there, and you will be reducing a lot of carbon footprints. So, for example, a smart building technology adopts home energy meters, which are IoT enabled. The IoT enabled home energy meters already which in place. As you know, BSNL is having and the government through Department of Telecommunication. So we are also currently starting the IoT projects, and also we are also providing the IoT solutions to our enterprise customers in various sectors and various areas. Even the IIT Hyderabad, we have also seen the IIT Hyderabad. They are also involved in various projects like energy meters and IoT enabled energy meters, or 5G related projects, and also involved in bringing environmental sustainable solutions to the communities. So, for example, the home energy meter. If you take home energy meters, the energy meter which are power meters, which we call, they're IoT enabled. What's the advantage is at the end of every month we'll be having a billing person. A billing person will be coming, and he will be taking the reading, and that reading will be basing on the reading. He will generate a bill, and he will print the bill and give it to us. So this is how the life cycle of maintenance, operation and maintenance of the energy meters will be taking place. If any energy meters are faulty, they will just raise a docket, and the person who is coming, the lineman or the concerned billing person will come and raise the docket, and that docket will go to the concerned engineer, and the new meter will be replaced with the acceptance or with the consent of the owner of the building. So this is how this will be there. But this, if you are keeping IoT enabled energy meters, what is the advantage is, maybe a home place, or it will be a big commercial establishments, or it may be the academic establishments or an IT establishment. The energy meters uh, automatically, without the involvement of the person, without the involvement of a billing person, the lineman, since it will be connected to the internet with the help of no, an SBC, a small computer. What will happen is, automatically the reading will be captured by the device as SBC, a small embedded computer, and through the internet it will be sending to the data to the control center. It may be the control center of uh, the Telangana state government, or the respective government. Respective governments will have their own energy department. So the energy department, like here TSSPDCL is there, the Telangana State Development Power Corporation Distribution Power Company will be there. So basing on the government energy supplier, whoever it is there, so he will get to the server. This energy meter will be providing which will capture the meter reading. It will simply upload the data to the control server, and that server will generate the bill basing on your plan, basing on your attributes that are available during the deployment of the energy meter. So it will generate the bill, and it will simply push the bill to your WhatsApp, or to your email, or to your SMS. So to whatever media form you want will be generated and sent. So thereby, this the advantage is sustainability. Of course, in one through the transportation of the billing person need not come to every let's say every meter, and need not travel, and need not see it. Automatically it takes place, and then a lot of fuel will be saved, and lot of energy conservation will be there. Of course, one side will definitely, everything will be having pros and cons. The pros, these are the pros, and the con will be definitely will be having impact when you are following smart building solutions. It will be having impact definitely on the employability, and of course we need to find out solutions for that. These are social solutions to improve the employability in elsewhere, different verticals of the new niche verticals which will be coming up, which niche areas where the possibility of employment will be there, because these opportunities will be there, and just find it out and just have to work on that solution. And coming other thing is the photos, on the roofs, apart from the no, green layers of the green grass or green landscaping, we also have to take the care of solar photovoltaic cells. Photovoltaic cells, the solar panels will be there, no? So there are different types of solar panels are there. Either we can connect as a standalone, or we can connect it to the grid. Now all the governments, all the state governments, energy suppliers, as well as the central government also in India, and also almost many major developed countries and developing countries, they're focusing on these renewable sources, mainly the solar energy, which is available in a abundance. So and in every if in almost whatever roof it is available, if you are if you are involving some capex in the solar plant panels, which we have done in order to improve the energy efficiency. And if you can look at all our major exchanges across the country, and many of the important installations, we have solar plants which are connected to the grid. So, and the grid and the governments are also buying the same, doing the same thing, they're executing the same thing. The advantage will be, you will be having a lot of advantage of the cost. One is the cost effect will be there, cost will be reduced, because whatever you are generating in excess of your usage, that will be sent to the grid. Suppose if your usage is more than the supplied by the solar cell, the grid will be supplying that energy, and you will be having, for reconciliation, you will be having a meter, the energy meter will be there, which will be having a reconciliation availability, and that is also in place, and that can be used. So the excess energy can be can be uh, made available to the grid, or if it is not required, no, we can also have scale up our resources to have much more sustainability that can be done. And even we can take have a small wind turbines also, because complete solar panels cannot meet your energy consumption needs. You can also take the help of a small wind turbines, and so small whatever it is feasible in the building. If it is a large establishment, we can have go for a 2-3 windmills, or if you can have a small establishment, we can have a one windmill which will connect to a turbine, and which will generate energy, and which will be having a use reduction of resources, the fossil fuels, and it will be having a good environmental impact. And you can see energy efficient lighting. That is also how this is also controlled, means in IoT enabled devices we will be having the sensors will be there. So in IoT device, suppose if you want to use an energy efficient lighting, the sensors what we have to do is we have to connect to SBC through the and this wireless technologies. We can connect to the number of wireless technologies that are there, which can be connected. The sensors can be connected to the SBC, that is embedded computers, which are connected to the internet, or you can say cloud. So these cloud technologies, wireless technologies, sensors, and the SBCs, single board computers, like Raspberry Pi, or you can be using so many blueberries, etc. So many of different options are there. These what they will do is, and sensors, like suppose no um, uh, the we will be using one proximity sensor. So whenever users or inmates or occupants of the room are entering that area, by the proximity sensor will alert the appliance. It will make the relay on, and the lights will be switched on. If inmates are going away, so the sensors they can detect it, and also they use the power energy as well. Excuse me, sir. Any doubt? Yeah. Uh, Thank you. So sensors are a touch sensor. Suppose if you are opening a room and entering a room, you can use touch sensor. Whenever you're touching the sensor, automatically the electrical appliances will be switched on. Maybe there are fans in the room, or maybe the lights in the room. And whenever you're going away, so that these with the help of the touch sensor, with the help of proximity sensor, with the help of the thermal sensors, or with the help of the temperature sensor, humidity sensor, moisture sensor. There's so many sensors which are very cheaply available in the market. They can be used for improving the smart building sustainability of the building. And for example, even we can have appliances like the air conditioning connected to the smart sensor. And if you are using green building, perfect green building solution, which are certified by the international Indian governmental agency, need not use AC also. The green building example which I give, recently I went to a college called as Hitam, Hyderabad Institute of Technology and Management, which is there in Hyderabad. So it is the best example I've seen. In this college, which is a green building certified college, you don't find any air conditioning equipment in the complete college. No AC air conditioning appliances are there. So they have designed, even in the peak summer also, they are not using the air conditioning equipment, and they are not at all deploying it. The advantage is the lot of energy consumption is there, as well as the environmental no, improvement, whatever the contribution is there. So this is having a lot of impact on the carbon footprints and greenhouse gas emissions also. So how the design of the structure in such a way that it is reduced. And the other things here are even sensors can be used. The light detection sensor, and even the burglar alarms will be there, and even the fire sensors will be there. So you can use the sensors, even to detect any hazards also, any fire is there, or any water sensor is there. So you can also prevent the loss of water, or you can also prevent the loss of energy through various sensors, through various IoT technologies to improve the smart building technology. And this also have the sustainability architecture, and also the green building is having huge community and social impact, as we have already discussed. Because when you are creating a positive impact on the local communities, and you are creating a positive impact on the environment, and obviously it will result in the community social impact also, because we are preserving the local your local communities. You are helping them, you are helping the local economy to flourish. You're helping the flora and fauna, existing flora and fauna to have minimal disturbance, and also vegetation to be have minimum disturbance. Then definitely the community impact will be there. So positive influence will be there, and the surrounding community. If everybody is happy around you, definitely will be happy. So that is also one of the key factor that is uh, considered for the sustainable architecture. So that what will the advantage will be? Healthy spaces will be the healthy office space will be there, and will promote local jobs, and hence the property value will be there. Property value also will be developed, because we are having the property, the land, real estate price also will be zooming up and increasing, because environmental is considered there, and it is sustainable. Water facility will be, water availability will be there, and good air will be there. Air quality will be there. Indoor environmental quality, IEQ levels will be good. So all these things are, even the triple IT Hyderabad, like Manu, they are also working on this air quality index. So they are working on the projects of no, uh, uh, different projects, like monitoring the air quality at different various places, and alerting them through the different dashboards, so that the communities will be aware of it, and will have no will make some measures to resolve these issues. They're also doing work wonderfully in that area. And the sustainable architecture mainly fosters a sense of community, that the community sense will be fostered, and also it will encourage social interaction. So these are the various positive ways that can be done by the sustainable architecture. And now coming, we are having seen one of the fundamental principles that are involved for sustainable architecture, having seen what is a green building and what are the sustainable architecture principles and the goals. Now, what are certification agencies? What are certification agencies which will be certifying the green buildings or sustainable buildings? You can say there are different agencies that are there. One of the world leading organization, which is operated in more than 180 countries, is called LEED. Lead is the most no you can say lead is the agency which is having the highest usage in many countries, especially for the green building certification. So basically, the lead stands for leadership in energy and environmental design. So LEED is a agency which will be involved in certification. It is US based organization, so it's globally recognized, and it is developed by the US Green Building Council. Green Building Council is that these are the this is a council which has developed this leadership in energy and environmental design. And the purpose is it's actually a framework. They, in this framework, a lot of criteria will be there, and the criteria is no to, in the entire life cycle, of the buildings, sustainable buildings. It may be the designing area, constructing area, or operating the building area. It will see that the no the environmentally responsible and resource efficient measures are taken by the owners or the people behind the green buildings, that they will take care of it, and then they will give the certifications. Okay. Whatever principles, fundamental principles we have talked about regarding the site selection, water conservation, or the material efficiency, or resource efficiency, or indoor environmental quality, or the development of the building, everything will be considered by the lead. Okay. And they have, how they certify is they will be having a point system will be there, and basing on the performance in various categories and various criteria, they will allot the points. And the points certification levels basing on, no, if you're having 80 plus point, they will be calling as platinum certified. If you're having 60 to 79 point, you will be calling them as, they will be giving a gold certification. 50 to 59 points, they will be giving silver certification. 40 to 49 points, they will be giving normal certification. So these are the different areas which the lead is working on. So leads the leadership and energy and environmental design for new construction of buildings, and for core and shell they are using, and then for also commercial interiors or existing buildings, and they not only design, also operational maintenance. So coming to the Indian context, we have IGBC. IGBC, like how I told, Green Building Council of US, which has developed this LEED certification. We can see the logo of the LEED. Similarly, IGBC logo, you can see Indian Green Building Council. So it is established since 2001. So 2001 means more than it is having the 23 years existence in India. So this also certifies, it's like a US Green Building Council. The equivalent of US Building Council in India is IGBC. So they are certified for new buildings. And in the lines of fleet, they have developed it. Green homes, green factories, green townships, and SEZs, the special economic zones also. So not only buildings, the green certification, sustainable architectures are also given for factories and townships, as well as the economic zones also. And also we can suppose, like, not only new buildings, even existing buildings can also convert to a green building. So they also provide certifications for that also. And for definitely governments, they will be having definitely some encouragements will be there. Some no, you can say the government will be doing some favors in terms of the benefits. Some governmental benefits will be there, and more or less the certification will have the positive impact, as I told you, commercially and socially, community-wise, everything they will be having a positive impact. And coming to the other important, the IGBC has given another certification called a GRIHA. GRIHA, they usually provide certification whenever the built-up area is more than 2,500 square meters, and and they also have a SVA GRIHA when the built-up area is less than 2,500 square meters. And for large developments also, they provide the certification. So these are the agencies which are there, which are the vital important ones, which in India and also US, I say, because LEED is the most popular one. You go to Middle East, or you go to the no, or maybe Central East countries, or maybe Australia, or you may go to the North American countries or South American countries. So more than 180 countries, LEED is having, IGBC is having the impact. So let's see what's the difference between IGBC and GRIHA. So just for understanding, I just kept a tabular form. So the IGBC, which is developed in India by the CII, Confederation of Indian Industry, which we will also discuss in our case study. It is launched in 2001, and whereas this GRIHA, which stands for Green Rating for Integrated Habitat Assessment. It is developed by TERI. TERI stands for the Energy and Resources Institute. So this is established in 2007, and international affiliation, as I told, IGBC is based on LEED only, and UGBC LEED only. Whereas this is independently developed. It has independently developed by the TERI, or in Indian context, because Indian factory and the fact of it also factored in Indian traditional practices, Indian context also is considered for GRIHA. Okay. And contextual focus, if you see, it is adaptable. It's have a broad international perspective is there. Whereas I told you, as no GRIHA keeping it is designed basing on the Indian climatic zones and traditional practices. So it is customized version of a LEED, you can say, GRIHA. So GRIHA, and of course, as I told you, everywhere focus is the same. Focus is on energy efficiency, focus is on water conservation, focus is on best practices in the design and selection. Same here also, occupant health, everything is done. And the other one important is the rating levels. Of course, IGBC talks about certification of silver, gold, platinum, whereas Griha certifies in stars, one star, 2 star, 5 star, like that. And of course, the assessment process, how the certification will be done based on performance, the design performance and predicted performance with some post occupancy verification will be done for the IGBC. Whereas for Griha, more emphasis will be there on the actual performance and post-occupant assessment. So these are the fundamental differences between the IGBC and the Griha. And when you are talking about, if you want to compare the certifications of rating agencies, the lead and Griha, it is the global context and Indian context. As I told you, this is developed by US GBC and this is theory. And in India, lead launched in 2001, whereas Griha launched in 2008, which you have already seen. And almost the focus is on same. Only the strong emphasis of Griha is in Indian context, Indian climatic conditions are considered. And the other thing is lead also is not designed for regional adaptations also, that is also considered. And these are the major differences you can see. And if you talk about the as I told you, um, the lead in the lead certifications will be like this. Already I told you about, if you are having 80 plus points, you will be called a platinum, or a different classification is there basing on the rating you are having. Whereas in Indian context, we have the up to 51 to 60 is 1 star, and 71 to 83 star, and 91 to 100 are 5 stars. So likewise, ratings are there. And examples of the buildings, so many examples also are given. The first the Indian green building certified building is which is a platinum rated building is CII GBC. Sohrabji Godrej Green Business Center, the GBC Green Business Center, which is there in the Madhapur, it is Madhapur area. So where it is located means it is opposite to Google CII building is there. We know it near the high-tech towers are there, no? So near the cyber towers, it is there. So I CII Sohrabji GBC. That is the first platinum rated. We'll be that case study also we'll discuss and down the slides. And then Griha certification exam. So many Griha certificates are there. You can go to the website and you can see the Center for Environmental Sciences and Engineering. Which has in the IIT Kanpur, located in IIT Kanpur, is also 5 star certified. And what are the green? If you talk about the criterions, as you have seen the fundamental principles of sustainable buildings, what are the criterion that green building certification agencies will be having? Mainly, I have taken the criteria of the Griha. So Griha certifying agencies, like criteria 1, this we have to follow every a company which are suppose we are going for consultancy, or which are going for implementation, we are going for the green building for to have the positive impact on the environment as well as the communities as well as the occupants. So this criteria you have to follow. So site selection is the first criteria, and for an existing landscape. So due to construction or compensatory depository forestation, suppose your deforestation is done for the construction of the site, construction of a building in a site. So we also have to transplant that area, those deforested plantation to a different area, or maybe in the same site in different location. So that also arrangement also should be done. The compensation compensatory arrangements you have to make. And criterion 3 is soil conservation. So not only soil conservation in the initial stage, but till post construction also the soil conservation should be there. And criterion 4 is designed to include existing site features. What are site features are there means maybe the height of the surface is not uneven surface is there. Still, that should be included in the existing site features, so that the natural beauty will be there, and also the damage to the environment will be as minimum as possible. And the criterion 5 is reduce the hard paving on site. That also should be considered hard paving. And the other criteria, sixth criteria, is outdoor lighting system efficiency. You have to use the outdoor lighting as much as possible in order to improve the energy efficiency. Seventh, you can see the usage of the, you have to plan the the resource utilities efficiently and optimize on-site circulation efficiency. So circulation means the air circulation or the wind circulation should be in such a way, the site as well as the building, in such a fashion that they are properly utilized. And other criteria is the sanitation safety of the construction workers have to be considered. Air pollution during construction, air pollution, the things like, no, suppose if you're constructing the site, you can use more prefabricated location the nearby site, so that the air pollution will be reduced. Depending on the site, depending on the area. Suppose there are a lot of communities that are living around the construction site, and you can use prefabricated sites like what we are doing in metros or the bridges or the flyovers. Those can be done. Of course, which will be having, we have to calculate the environmental impact, whether the transportation will be having more impact or whether the pollution will be having more impact. That should be considered, and that should be no a criteria. That criterion should be taken into picture. And the other one is the landscape water requirement also should be considered. Landscape water requirement should be as natural as possible. So natural rainwater or rainwater recycling and all these things are to be considered. And buildings water usage, as you told, discussed about the low flow waters, and then recycling of the waters, and all these things we can use. Water use during construction, efficient usage, and optimize building design to reduce the conventional energy demand. Conventional energy demand reliance on more renewable sources, and optimize energy performance of the building is special within special comfort limit. So comfort limit should be there, and energy performance also should be there. Energy performance means lighting should be proper, and the cooling should be, cooling effect should be there. The comfort limit should be, there should be comfort limit, as well as optimization of the performance should be there. And utilization of fly ash. So a lot of fly ash will be there that can be utilized, which are fly ash which are produced by the industry, rather than using the normal sand, which is having a lot of impact on the river beds or the sea beds. Utilization of fly ash in the building structure will be greatly improving the your carbon credits. So the other one is the 16th criterion will be the reducing the volume, weight, and time of the construction, and then use low material in the interiors as much as low, or using the environmental materials like bamboos, etc. Renewable energy utilization, renewable energy based hot water system, the geysers, avoiding as much as possible, and using solar plants and based geysers, etc. And wastewater treatments and sewage water treatments, and the water softeners to reduce the hardness also greatly impacts uh, the environment. Criterion 21 talks about the water recyclings, and criterion 22 talks about reduction of waste during construction, and that 23 talks about waste segregation. Even water waste that is generated during the construction or the operation, that should be segregated, and that should be recycled, or that should be renewed, or that should be reduced, or you have to do some, you have to take some response to no, to transport it and to a proper place, to utilize it in a different location. That plan should be there. And storage and disposal of the waste, resources recovery from the waste. So resource recovery from the waste, which we are talking about. So from 22, this all 21 to 25 talks about the waste and water recycling. And 26, if you talk about 26, that they are focusing on the indoor quality, indoor environmental quality means air quality, clean air production. See, usage of low paints and low PVC paints, adhesives, and sealants, and also ozone depleting substances. While using the refrigerators, you have to take care that ozone, the refrigerants are not used, having less effect on the ozone layer. Ensure water quality, and also noise levels, water outdoor indoor noise levels by using proper insulations. If you use it, then also will be having it will be having more comfort and well-being of the control. And tobacco smoke control, and provide the minimum level of accessibility for persons with disabilities, PWD people are also to be considered. Energy audit and validation, what are the measures we are taking for energy auditing and validation? and buildings operation and maintenance, how we are taking control of building and operation. So these are the various, around 33 criterion are there for real building certifications. So these are the criterion which are of the Griha development. As we have seen, the Griha, the green rate, which is known as green rating for integrated habitat assessment. So Griha, which is developed by the Terry Indian context certification, green certifications, they are taking the criterion of around 33 criteria are taken into picture for certification to the different establishments of the forms of the buildings. And let's talk about quickly. I will take you through the case study of CAI. So Harabji Godrej Green Business Center. So it's all called as GBC. So it is the first oldest lead platinum certified agencies. I hope by seeing it you remember it. From outside also we can see solar panels will be there. Outside we can see that the rooftops are green covered roofs, green grass covered rooftops will be there, thereby reducing the indoor temperature. And they use solar panel for energy efficiency. They also have the wind pipes are there just to reduce the usage of AC air conditioning unit. And also they are using some other initiatives for the occupants. They're giving preferential treatment for cyclists, carpoolers, and also users of bicycles are now encouraged in the campus. And also battery operated vehicles are there from long back, and which are reducing the emissions by up to 60%. So these are the various practices they are doing. And site area is they have taken see what all the criterion of lead they are considered. The site area, they have seen that maximum the lowest technological disturbance is there within 40 feet only, and natural topography is maintained there. Materials also mostly local virgin materials within the 100-mile radius also used, and mostly they have used construction waste only for the disposal of the material for construction. And also you can see 77% of the building material were contain the recycled contained fly ash, and bagasse or recycled paper aluminum is used. And also waste management plan, they ensured that 96% of the construction waste was recycled. So 96% they are recycling it. And air quality improved by more than 15 to 20%. So their air conditioning load is reduced by 15 to 20% because they are using aerated concrete blocks made of fly ash or facades, and the low VOC materials for paints. And air quality they are taking into consideration. And for cooling, as I told you, this wind no, you can say these either called as wind catchers, or they can be called as wind scoops or bugbears. These are there in 2 or 3 such wind towers. We'll be calling as wind towers, but actually, in fact, they are called as wind catchers. So for natural ventilation, because they will be tall structures. In the GBC whole has around 2 wind towers are there for energy savings only. So what they are doing is, so these wind towers supply air cooled by up to 8 degrees centigrade to the air handling units. So air handling units significantly what they will do, they reduce the load on the air conditioning system. So these wind towers are in combination with the air conditioning system, thereby the cool air will be provided to the air conditioning system. So whatever is available, and you will be having a lot of energy efficiency will be there, and the natural environment is taken care, and indoor quality air also will be improved. And heavily insulated roof further contributes to the reducing the building cooling load. So these are all different things they are taking into consideration. And water efficiency is considered. So permeable pavements are they're adopting, and also wastewater treatment is there, and low flow fixtures are arranged in their buildings. And energy efficiency, they are using green roof, covering 50% of the roof area they covered. And solar panels are reducing their they're also contributing 20% reduction in the energy demand. So in all aspects, whatever criteria we are following, with discussing, and in the green building certification, they're following energy efficiency. And also this GBC, the Green Business Center, they no it has carried more than 1950 audits so far. So 1950 energy audits, so far these are from the website only. So this certified from their website. So including the countries, like so many countries, the energy audits, they have done it. And IGBC certification is there, Green Pro Eco Label certification is there for using sustainable products, Green Co certification is there for using holistic mechanism for improving the ecological footprint, renewable energy they are using, and then the Green Energy Council also they are meeting. So this is the best example in India, and fortunately we are having that CII Sorabji GABC very near to our campus. The challenges in architecture is obviously there will be challenges there. So financial challenges will be there, technical challenges will be there. You have to smart technologies, means some technical capabilities are required, and also for implementing the green buildings, definitely some financial challenges will be there. So of course training and education will be avoiding these misconceptions and the capacity. That is one thing. So what are the future trends in this? If you take the future trends, you see that the stats from right now 2024 in this industry. If you take 2017 figure, it was around 7.4 billion. Now it is around 38.2 billion in 2027. So that by using the technologies like all these latest technologies like IoT, cloud computing, and AI, by using all these technologies also, the green technology is improving, and the market size is improving, and the trend is in coming years still it will be improving. So innovations in design and innovation material also will help in integrating those technologies in the green building. And what is the, definitely there will be a role of government and policies will be there. So because government suppose government provides good incentives or grants and regulatory practice, regulations of the maybe the RERA, ZATERA, maybe in different countries different regulations will be there. It will definitely improve energy efficiency and sustainable design. So there should be a collaboration should be there between the government and the private, so which are essential for the progress of the sustainable architecture. And education awareness is very important to the public, as well as seminars, webinars should be there. Architects and builders, civil engineers, and public should be should be thoroughly aware about the sustainable practices, which are the benefits from the green buildings. Okay. And the global perspective, if you see, it is and the population is rising 9.8 billion by 2050. So it will be having a lot of pressure on the resources. So resources will be there. So if you want to have the sustainability, if you want to provide a good environment to our next generation, to our children, to the new, and then we have to see that the worsening of our current environment should be as less as possible, and we need to follow different approaches for sustainable architecture. We need to take the help of technologies. You have to take the help of smart technologies. You have to take the help of the business communities, local communities. And since it's a complex and multifaceted issue, there is no easy solution. We have to only collaborate, work together, public establishment, private establishment, and different organizations come together to have a sustainable future for everyone. And I can see here, if you take even the other countries, global perspectives in India, as I told, Biha is there. And in China also, they're having a green building evaluation is there, which is rapidly increasing. Middle East, they're having, if you take Dubai or Qatar, Estidama or GSAS is there, that is also increasing. And they're also following the water conservation and arid climate areas, energy efficiency is there, cultural sensitivity is there. And if you take US, I already talked about LEED, and Canada also LEED is there. European Union, they are following BREEAM, Building Research Establishment Environmental Assessment, and Australia Green Star. Likewise, if you take globally, all the countries are focusing on the sustainability practices. So finally, this practice is a vital step towards a better future for our children, for our future, next generation. So every government should make this collaborative effort, and the private communities, public, everybody should be involved in this collaborative efforts, and which will promote and realize the potential of the green buildings. And I have taken some references from various websites and also from the LEED and then GREHA and GBC websites. And thank you for the participation, and thank you for the attention. Any doubt?
Thank you, sir, Mr. Vivek, sir, for sharing your knowledge and experience with us. We sincerely appreciate your contribution to this FDP. Thank you, sir. Thank you very much.
Thank you, ma'am. Thank you.
Now I have pleasure to introducing Dr. M.A. Zabbar. Dr. Zabbar is currently serving as the professor and head of department of computer science and engineering at Vardhaman College of Hyderabad. With a specialization in artificial intelligence and machine learning, Dr. Jabbar has made significant contribution to both academic and research communities. His research in AI and ML has earned him numerous accolades, including the Best Faculty Researcher Award from the CSI Mumbai chapter, the Best HOD of the Year's Award from CSI, and the Outstanding Leadership Award from the IEEE Hyderabad section. M.A. Zabbar has been honored as the one of the 2% scientists worldwide at the feature world ranking of top 2% scientists by Stanford University's Answer.
Rakesh, sir? Dear participants, we'll be having a break of about 5 minutes. Then we'll start off with the next session by Dr. Akhila Jabbar, sir. Uh, Good evening, Jabasu.
Yeah, good evening, madam.
So just now we have completed off with the first session of
Okay.
this. We'll have a break of just a few 5 minutes. Then we'll start off with the next sessions.
Yeah, no issue.
Okay. Thank you, sir.
Yeah, good evening all. I have the pleasure introducing Dr. Akhil Zabbar Mirza. Dr. Zabbar is currently serving as the professor and head of the department, Computer Science and Engineering at the Vardhaman College of Engineering, Hyderabad, with a specialization of artificial intelligence and machine learning. Dr. Jabbar has made significant contribution to the both academic and research communities. His research in AI and ML has been earned him numerous accolades, including the Best Faculty Researcher Award from the CSI Mumbai chapter, the Best HOD of the Year's Award from CSI, and Outstanding Leadership Award from the IEEE Hyderabad section. M.A. Zabbar has been honored as the one of the top 2% scientists worldwide, as featured in the world ranking of top 2% scientists by the Stanford Universities. He is a senior member of globally recognized organizations such as the IEEE and ACM, and is a lifetime member of Computer Society of India and the Indian Science Congress Association. I would like to invite Dr. Zabbar to begin his session. Please join me in the welcome him. Dr.
Yeah, thank you,
Zabbar,
madam,
please.
for your
Yeah,
thank you for your kind introduction. Let me start the session.
sure. Sure.
Hope the screen is visible.
Yes, sir.
Yeah, okay. Thank you. Thank you, Manu, for inviting me as a resource person to deliver the applications of artificial intelligence and IoT in energy management. Today's the topic of discussion is the role of artificial intelligence and IoT in energy management, which is going to transform energy systems for a sustainable future. Today's agenda, first we will discuss about what are the energy management challenges, why there is a need for integrating technology in energy management. We'll also discuss about AI as well as IoT. Then finally, we'll discuss about AI and IoT in energy management. Let us go through what are the energy management challenges and what are the key issues as well as the solutions. The first, the energy management challenge is there is an increasing energy demand. As we all know, without the power, okay, it's very difficult to survive. 100 years back, okay, when the current is invented, then I think they have not imagined it is going to transform the entire world. The artificial intelligence, which is going to be okay rapidly going to change the world. And as the globalization, as because of the industrialization, everybody needs the power. So when there is a huge demand, there are issues will be there are challenges will be there. And now if you can see across the globe, everybody is speaking about smart cities, smart energy management, how we need to safeguard our energy with little bit of resources, how we are going to reach, or how we are going to satisfy the daily needs of population. So very first challenging is increasing energy demand. The challenge is the rapid growth of industrialization and urbanization. As the population increases, obviously energy demand is also going to increase globally. What will happen if this energy demand goes on increases exponentially? Then because of the limited resources and because of the infrastructure, limited infrastructure, and because of the distribution system, there will be impact, the strains in energy resources, infrastructure, and distribution system. Another challenge is energy efficiency. Generally in we can also sometimes encounter there is a the power cut, or it may be low power. It means that we are not getting efficient power supply. So the challenge, what is the challenge? Reducing energy waste and improving efficiency in buildings, industry, and also the transportation. From energy generation to the transportation as well as the distribution, there is the possibility that there is a wastage of the power supply. So how we are going to handle this power supply? What will be the impact? Inefficient systems will lead to higher cost and also greater environmental impact. This is another challenge. And the third is integration of renewable energy. What is the challenge is incorporating renewable energy, like it may be solar and wind. Now the government is encouraging the organizations, even individuals, to go with the solar. How this solar as well as wind power is going to integrate with the existing energy grids. We already have energy grids. There are already established companies are there. How we are going to generate this renewable energy and how we are going to integrate this renewable energy, like it may be solar and wind, to our existing energy grids. There is also another challenging one. And if we want to integrate this renewable energy, it may be solar or wind. Assume that I have installed the solar panels in my house. I want to give it give the power back to the existing energy grid. I want to give the power to, I want to sell the power to the company. So how this will happen? So in order to integrate this renewable energy, which requires technological upgrade and also balancing supply demand fluctuation and storage solutions. And another one is aging infrastructure. If you can observe, we have various the power grids are there. It may be Nagarjuna Sagar, or it may be Sri Salem, or it may be another. They are actually built 100 years back. So what we have to do with this outdated power grids, and how to make the power from that aging infrastructure, that is also another challenge. So majority of the countries, they will rely on this outdated power grids, obviously, and also the energy system. If we completely depend on this aging infrastructure or outdated infrastructure, then there is a risk of power outage and also the inefficiency in energy delivery. We cannot supply the power to the individuals as well as the companies. Energy cost, and if you can observe, there is a volatility in energy prices due to global economic condition. If you observe Telangana, the power rate is different. If you go to Maharashtra, the power rate is different. If you go to Karnataka, that is also different. If you go to northeastern parts, the rate of energy is different. That is also another challenge. How we need to overcome this volatility in energy prices, because the difference in energy prices is because of global economic condition, political instability, and as well as the natural disasters. If you can see, in Telangana, we have the coal mines in and around the Telangana. So the cost of supplying the coal from various coal mines to grids is very little. The same one, if we want to supply the coal in order to generate the power from the nearby areas or the coal mines in the Singareni collieries to, let us take, it may be Bombay, or it may be Madras, or it may be other states. It will take a lot of cost. So there may be change in the energy price. What will be the impact is the higher operation cost for industry as well as the consumers. As I mentioned, there are the different operational costs for the different states. So that also we need to minimize. Another is environmental impact. So if you can see coal mines, now people are coming with open cast mines. The coal will be used for the power supply. And coal will be burned for the power supply. So if the coal is burned, so obviously there is a huge carbon emission. So how we are going to reduce this carbon emission? And we want to give a clean and green energy. For that, we need to have strict environmental regulations and also public demand for sustainability. And another challenge is energy storage. The power supply in winter, or it may be rainy, is completely different when there is a huge demand in summer. Summer, obviously, temperature will be high and everybody prefer to use the ACs. So power supply will obviously huge. So how we are going to balance the power supply? And is there any possibility to store the power which is minimally used in winter as well as the rainy season? So we need to think about that one. That is also another challenge. Developing affordable and efficient energy storage solutions for renewable energy is also one challenge. And assume that we are coming with huge solar panels as well as the wind. If the power supply generated more, but if we don't have storage capacity, then it is difficult to store this renewable energy. Limited storage capability will hamper the reliability of renewable energy. Nothing but you are going to store in the batteries, but how much? And another is data management and monitoring system. And now on the majority of the power grids, they are operated with the help of IoT devices. And managing large volumes of data from smart grids. I think even we also, everybody who knows, the governments are insisting to install the smart meters. They want to know how much power supply is given to the individual houses, in order to find accurate power supply. They are coming with smart meters. So for that one, we need to have a proper mechanism that is called data management and monitoring. Managing large volumes of data from smart grids, smart meter, as well as the IoT devices for real-time energy system. So if we want to have smart meters, earlier the persons who want to take the meter reading, he has to come manually. He has to verify the meters. He has to manually record previous month reading and this month reading, and he is going to calculate. So now if you can observe, there are smart meters are there. Just he will bring a machine, he will scan, the automatically previous month meeting reading is already stored. It will immediately calculate, within minutes we'll get a bill. So for that one, we required advanced analytics tools. And another challenge is cyber security measures. If we are coming with smart meters, then again there's a possibility that they may tamper the smart meters also. So what measures we have to take in order to have efficient power supply? And another is policy and regulation. Different regions will have different policies and different regulations. As I mentioned, the Telangana will have different power regulation. Andhra Pradesh will have different power regulation. If you go to Jammu and Kashmir, it will have different power regulation, depending on the availability of the resources, depending on the power supply demand. So the challenge is navigating diverse and evolving energy policy and regulation across the region. What is the impact? If we don't solve this one, then obviously compliance can be complex, and also it will be costly for business. If a business people want to come and set industries in a state, first they will see, they'll observe, okay, whether the power supply is okay, efficient, what is the regulation, how much cost they are charging for the individual industries. That is also another challenging one. And another is behavioral challenges we will generally face. Encouraging individuals and organization to adopt energy efficient practices. Okay, generally, even you can also observe the industries or institutions, they'll keep a board. Kindly switch off your fan and okay, light when you are leaving. Okay, they want to save the power. That's why encouraging individuals as well as the organizations to adopt the energy efficient practices. And the impact is resistance to change and a lack of awareness, which will hinder the progress. Now, as of now, we have discussed about what are the challenges, power or energy challenges. There are various challenges. It may be infrastructure, or it may be regulations, or it may be policy, okay, or it may be the integration of new technology. There are various challenges. But what are these? How we want to overcome the power or energy challenges? First is we need to promote smart grid technologies. Like it may be, if you go to any industries nowadays, you can find all the CNC machines, computer numerical operated machines we can see. So similarly, we need to promote smart grid technologies, invest in renewable energy infrastructure. You need not put much effort. You need not put much revenue for this renewable energy. And we need to foster energy efficient buildings as well as the industrial practices. We need to strengthen the policy framework to encourage sustainable energy use. We need to encourage public-private partnership for funding as well as the innovation. If you want to encourage the industries, if you want to encourage the organizations to use the renewable energy, initially the government used to give some kind of subsidies, and they have the public-private partnership. So similarly, we need to encourage the public-private partnerships to fund for this renewable energy infrastructure. So these are the various solutions in order to overcome the power challenges. One is we need to go with the smart grid technologies. We need to encourage to invest in the renewable energy. We need to encourage energy efficient buildings, which is called smart buildings or green buildings. We also strengthen policy framework to encourage sustainable energy. We need to encourage public-private partnership for to use this renewable energy. And the last and the useful one is we need to use AI, machine learning, and IoT for real-time energy monitoring and optimization. As I mentioned in the previous slide, using of AI, machine learning, and IoT for real-time energy monitoring and optimization. If you monitor the energy, if you monitor how much power supply is generated, if you monitor how much power supply is distributed, if we monitor how much power supply is transported, then we can save a lot of power supply. As we mentioned, the like smart meters, where it can record the power supply, and easily they can find out whether is the possibility of theft of the power supply or not. And also based on that one, we can also optimize. So it is the one of the latest and trending challenge for the power supply, that is using of AI, ML as well as the IoT. As we mentioned IoT, let us go through what actually the IoT is. IoT stands for Internet of Things. Okay, simply we'll call, these are used to connect the world around us. internet. Okay, IoT stand for Internet of Things. We are connecting various devices to the internet. Okay, Internet of Things. Things we have, you have the various things. We need to connect these things to the internet so that they can interact with each other. Let us take here, I am presenting through my laptop, right? Through the Google Meet. Whatever I am presenting here, once I share my PPT, it is visible to all the participants, like 80 or 90 participants, it is visible. And you can see what actually each slide represents. And you can also able to hear my voice. It happens because of the internet. Similarly, I want to connect various things, devices, okay, through internet. That is called Internet of Things. Connecting devices to the internet for smart interaction. Example is smart homes. It may be wearable devices and also connected cars. There are so many, plenty of applications. How IoT is going to work? What are the various core components? What are the main components of IoT? If we want to make sure the things are connected and things are able to talk each other, okay, what are the basic components? One is sensors and devices. You should have the sensors with senses, and we should have the connectivity, data processing and analytics. The same, if I am speaking from here, my voice, okay, will be converted and it will be delivered to each of you. Okay, and user interface. I am sharing the PPT through, let us take a platform called, okay, Google. Right. So these are the various components of IoT. You should require sensors, which senses, connectivity, you require connectivity, you require data processing and analytics. If I am sharing the PPT, same PPT will be visible to you. So background, okay, you are processing. And also you require user interface. These are the core components of IoT. Each IoT will have 4 layers. This is called IoT architecture. First layer is a perception layer. Perception is, okay, it is also called as the physical layer. Like sensors as well as the devices will comes under perception layer. You can observe in the right hand slide, RFID, sensors, camera, actuators, they all comes under perception layer or physical layer. And on top of the perception layer, we will have network layer. We will have the network layer, okay, where the devices are connected, like it may be Wi-Fi or it may be Bluetooth or it may be 5G. And another on top of the network layer, we will have a middleware layer, or we can also call it as a data processing layer. So in order to process the data which is, okay, recorded through sensors, or it may be cameras, or it may be RFID. So for this, we will have data processing layer, generally cloud computing, or it may be edge computing, or it may be database, okay, will comes under this middleware layer. And finally, we will have application layer. Application layer will be used for end user services, like it may be smart grid, smart healthcare, smart building, or it may be smart transportation. So we have 4 layers for the IoT. Top, we will have the application layer, then middleware layer, network, as well as the perception. But actually, if you want to remember, we have to go with the bottom to the top. Why? Because data will be captured through the sensors, cameras, as well as the actuators. Okay, then the whatever the data is captured, you require some kind of network. Okay, it will be goes to Zigbee or Wi-Fi or Bluetooth. You require some kind of data processing. For that, generally we'll use cloud. And finally, okay, the users interact with the application layer. So this is the architecture of IoT. What are the various applications of IoT? As we know, we said IoT stand for Internet of Things. The things are devices which are connected, okay, through the net, is called IoT. We also discussed about various components of IoT, and we also discussed about 4 layers of IoT, right? Like it may be application, perception layer, okay, middle layer, and also data processing. So what are the basic applications of this IoT? Why there is a huge demand? Why everybody is speaking about IoT? If you can see the various the domains, first domain is smart cities, traffic monitoring. You can observe cameras are installed in each and every, okay, junction. They'll capture your speed. If you cross the limit, okay, automatically the challan will come to you. And also waste management, as well as the energy, the management. Here, if you can observe the waste management, this real-time example I have seen when I visited 4 or 5 years back when I went to Bahrain. So there they have the different dumps for the garbage collection. So when the garbage is full, so it automatically gives the hint to the municipal officers or municipality. There the people immediately come, immediately, okay, clean the garbage. They'll take the garbage and they will clean. So we were surprised because the morning there is a complete full, okay, dump, and by afternoon or evening it is immediately clear. Actually, they are using the sensors installed into the dump yard. Whenever it is okay, full, it is giving the, okay, the notification to the municipal authorities. So the IoT have been used in traffic monitoring. You can also observe the in ORRs or okay, in high traffic areas, the people will have with the guns. It's called a speed gun. It is going to identify, okay, how much speed you are going. Then based on the speed, they are going to give the challan. And another application of IoT is healthcare. Okay, smart wearables. We know everybody is, okay, using the smart watches. Smart watches, it will record your heart rate. It will record your BP. Okay, and it will alert you if your BP or heart rate is okay, the increases with the permissible range. And IoTs are also used for the agriculture, precision farming, irrigation management. And the another application of IoT is Industry 4.0. As at the very beginning I mentioned, majority of the industries are going with CNC machines, and also they are going to have automation in the industry. If they want to have the automation, if they want to record, then obviously they have to go with the trending technology, that is nothing but the IoT. So apart from that one, there are various applications of this IoT. It will sense the devices, it will give the data will be processed, and finally it will be given for the analysis. So these are the various applications of IoT: smart cities, healthcare, agriculture. And if you can in the agriculture, generally if you observe in Germany or the US, the farmers, they will have the hundreds of acres. Now here they are effectively using this IoT as well as the artificial intelligence. They are having the hundreds of acres of this apple field. Okay, if manually, if they want to pluck the apple, whether it is properly ripening or not, so what they will do is they have one camera which will, okay, installed onto a machine. When the machine will goes to each and every tree, it will scan the camera will scan the apple. If it is in the ripening stage, it means it is in completely red color. Okay, it will give hint to the okay machine. The machine will alert it. It will go and it will pluck the apple. Right? Means the sensors have been installed in the camera. They will scan the apple, whether the apple is in the red color or not, and immediately, if the apple is a red color, it will be given to the background application which is installed with the machine learning algorithms. Immediately it will compare and it will say, yes, it is in the ripening stage. You can plug the apple. This is the beautiful application we have seen in the agriculture sector. And another is predictive maintenance as well as the automation. So what are the IoT technologies used? Communication protocols. Why? Because the name itself indicate IoT. You are connecting the devices. If you want to connect the devices, you need some kind of mechanism. You need some kind of communication technology. So we have the various communication protocols. Okay, MQ2T, COAP, as well as low range. And another IoT technologies, hardware platform, like it may be Arduino, it may be Raspberry Pi. Cloud services, there are different cloud services used for the IoT. Amazon Web Services, as well as the Google Cloud. These are the various IoT technologies. What are the advantages of IoT? Improved efficiency and automation. One minute. Okay. Advantages of IoT is improved efficiency and automation, better decision making through real-time insights. As I also told you, one of the best application is ripening of apples, plucking, enhanced user experience, and obviously cost savings. These are the various applications of IoT. When you are using the IoT for different applications, obviously, another side of the coin, you will have the challenges in IoT also. One is security and privacy. When you are going to sense the data, obviously there is a security issue. So security and privacy is also one of the concern. Scalability, how you are going to increase the usability of the IoT, and how you are going to use the various devices which are connected to the IoT, and high initial investment. These are the various challenges of IoT. Security, obviously, if you are going with smart houses, right? If you make your house as a smart, and you install some kind of cameras in your front door, whenever you goes to the front door, it has to open. It will scan your face. It will open. Assume that if somebody had breached, and if your system, your smart door, will also allow some other persons into your home, then it will be a privacy issue. So that also we need to think. These are the various challenges. And another is scalability. How you are going to take so many applications, how it is going to operate with various kinds of devices, and also initial cost. Despite of the various challenges, how this IoT is going to be used? It is going to be used with the integration of artificial intelligence as well as the machine learning. And another is IoT is going to expanded in 5G networks also. Why? Because the basic heart of any IoT is the communication. It has to communicate with the various devices. That's why the IoT can be expanded in 5G networks. Sustainable IoT solutions. And if you can observe the growth projection of IoT devices or the connected devices by 2030 is 1 billion. 1 billion devices will be connected through internet by 2030. So there is a huge growth huge demand for this IoT. In the future, or the scope of IoT is, it is going to be interconnected with AI and ML. It is going to be expanded, or it is going to be integrated with the 5G networks. It is going to be used for sustainable IoT solutions, and there is a huge demand for the IoT, and it is expected that the growth projection of IoT by 2030 is 1 billion connected devices. What is the importance of integrating this technology in energy systems? We have two separate the portions. One very first portion we discussed is what are the challenges of energy. We have limited resources. We have aged infrastructure. Population is growing. We have limited infrastructure. That's why we have various challenges. And we also identified various solutions for that one. One is you make your grids as smart. And last point we discussed is integrate IoT, machine learning, as well as the AI into the energy system. If we integrate this trending technology into the energy system, at some point of time, we may reach the demand of energy systems. So what is the importance of integrating this technology into the energy system? The motto is for efficiency, for sustainability, and also for resilience. The first is enhanced efficiency and optimization. You can improve the efficiency of power distribution, power generation, and power transmission. And also, once the power supply is transmitted, we can monitor the power supply using smart meters. So the very first is real-time monitoring with IoT and artificial intelligence. If we can integrate IoT, AI with our smart grids and smart meters, then obviously, optimal energy uses will take place. And the second is automation will obviously minimizes the energy waste. If we install smart meters, if you compare the old meters with smart meters, if you install the smart meters, it will record each and every one. You don't find any wastage. So it will minimize the energy wastage, by adjusting the flow based on the demand. And another is you can based on the energy usage. Let us take if we have the four phases in a colony, 1, 2, 3, 4. If phase 1 using reduced power supply, and there is a demand from the, let us take road number 4, then the power which is to be transmitted to 1 will be minimized, will be reduced, and it will be converted to the road number 4. That is demand response system, which will reduce strain on the grid. And another is sustainability and renewable energy integration. If we want to integrate the renewable energy like solar as well as the wind, if we integrate the renewable energy to the grid, so it will enable seamless integration of renewable energy like solar and wind, and advances in energy storage, which will ensure consistent power supply. There will be no power cuts if you effectively use the solar and wind. And if I use the technology for integrating the solar and wind with regular power grids, which will reduces the greenhouse gas emission through optimized energy usage. And also another is cost reduction. Obviously, if we use the technology, which will lower operational cost with automation, which will provide energy saving for consumers through smart devices, and predictive maintenance prevents costly failure and downtime. As very first I mentioned, winter, okay, rainy season, the power supply demand is minimum, and when it comes to the okay summer, the demand is huge. Okay, and sometimes, okay, all of a sudden the temperature will go high. If the temperature will go high, obviously the energy, the power supply demand is more. So if we can predict, okay, the temperature, and accordingly, if we can supply power, if we maintain the power supply, then obviously, okay, we can minimize the failures and downtime. Sometimes we may hear this, okay, grid is down. I think 6 months or 1 year back, we have seen in the news that NTPC power grid is failed and it is down. If it is power, if the grid is down entire, there is a too much of obstruction in the power supply. So we need to predict, okay, how the power supply has to be distributed to different areas. How it will happen? Okay, we have to use the technology. Then only it will be possible, okay, to identify the power supply demand. Grid resilience and reliability. Microgrid and distributed energy resources will ensure continuous power supply. And another is smart systems. They will quickly identify and isolate faults during outages. If the grid are installed with this trending technology, then they can easily identify the faults during the power supply. And the advanced cybersecurity measures will protect grids from cyber attacks. When we are saying smart grids, then there is a possibility that, okay, there is a security breach. Whenever any device or component, if is connected to the net, then there is a possibility of cyber attack, including the power grid. If the power grid is connected through internet, then there is a possibility of cyber attack. If somebody enters into the power grid, if he takes the control of the power grid, if he intentionally stop the power grid, if he intentionally make sure that the power grid is failed, then obviously there is a, okay, huge loss. So when you are going for the smart grid, then obviously at the same time we need to make okay, sure that the advanced cybersecurity measures, okay, has to be used in order to safeguard the power grids. And empowerment of consumers. Smart meters and apps provide control over energy usage. As very beginning also we mentioned smart meters. And dynamic pricing models benefit both provider and consumer. Here, let us take, we all know, okay, the power supply 230 volts power supply will be given. Let us take, you are using very minimal power supply. Even though you will be charged, the minimum charge you will get. You assume that if you are not using the power supply, okay, and you want to give back the power supply, let us take only 50% you are using, and you want to give 50% back to the, okay, the poles, 50% back to the grids. Okay, now if you have this technology, then you will get a dynamic pricing. If you use, let us take 100% power supply, you will be charged, assume that 500. If you are only using 50%, okay, minimum 50%, then you will be charged accordingly. But actually, what is happening, whether you use or not, they will have the minimum, okay, minimum pricing you are going to get. But if this is implemented like dynamic pricing, so obviously, okay, both providers as well as the consumers will get benefited. This will happen only when the power grids, okay, or smart meters are equipped with the IoT as well as the AI. And technologies like solar panels, if the solar panels are, okay, equipped with the IoT, then, okay, energy independence will happen. Data driven insight and innovation. Big data analytics improve energy forecasting. You need to identify the, okay, the demand of energy. So you need to forecast, you know, how much energy is going to, okay, the demand for the, let us take summer, which area there is a huge demand, which area, okay, there is a less power demand. You need to identify. So there are so many technologies have been integrated. One is big data analytics, and another is research and development in innovative energy solutions, and another is accelerate adoption of new technologies like hydrogen power. Now everybody is speaking about hydrogen power. And another is environmental or social impact. Optimized systems will reduce emission and combat climate change. And another is expand energy access to remote and undeserved regions. If you save the power, the power which is saved can be given to the remote locations. And at the same time, okay, we can create a lot of jobs in technology focused energy sectors. Okay, these are the energy management challenges: increasing energy demand, inefficient energy usage, environmental concerns, integration of renewable energy sources. This is the application of IoT in energy systems. In power systems and power grids, the IoT is a key element in monitoring, controlling, and optimizing different aspects of the electric grid, such as generation, distribution, transmission, as consumption, which is the key element. If you can observe in this cycle, okay, IoT is in the middle of this one: regulation and markets, utilities and generation, demand side services, okay, and also transmission. Interconnected devices. When we are speaking about interconnected devices and sensors, which will collect data that aid in decision, thereby used to improve the reliability, efficiency, as well as the grid stability. If you can observe this entire one, the IoT is in the middle, which is a key component in monitoring and controlling the various aspects of the power grid, like power from the power generation, distribution, transmission, and consumption. The worldwide Internet of Things in energy market, you will be surprised, was estimated to reach about 35.2 millions by 2025. This with an annual growth rate of 11.8% from 2020 to 2025. Means there is a huge demand for the IoT components, especially in the energy sector. Means people are ready to invest, okay, $35.2 million by 2025. And the global energy consumption has risen rapidly because industries are growing. Everybody needs power, okay? And this energy consumption is going to rise until 2045. Now, how we are going to manage, right? So hydropower and renewable energy consumption will increase between 2045 and 2050. Hydropower and renewable energy consumption. Now, when there is a no coal, where the people has to go? So obviously they have to go for the hydropower and renewable energy. Okay, they have to use solar as well as the wind. The demand for the wind and solar power will increase okay, in between 2045 and 2050. They will reach by 30% worldwide. And another is IoT technology will lead to an overall reduction in the consumption of electricity. That is 1.6 petawatts in 2030, as well as the decrease in the use by 3.5, okay, by 300 billion cubic meters. Means if you can observe the demand by 2045, there is a huge demand for energy consumption. And when there is a huge demand for energy consumption, obviously people has to look after hydropower and okay, the renewable energy. So obviously 30% of okay, worldwide energy uses will increase. In order to meet all these demands, then there is only the one option called, okay, integrating IoT as well as AI. So there is a huge demand, okay, of $32.5 billion by 2025, right? And these are the various applications of IoT in energy management: real-time monitoring of energy usage. Example, IoT sensors will be used to track the machine energy consumption in factories. Another is smart metering and demand. Example is mobile apps alerts during high demand periods. Another is IoT enabled smart grids, which are used to integrate renewable energy, okay, with the in order to balance the supply demand. Smart okay, thermostats and energy monitors, which are used to detect the faulty appliances also. So if the solar panels are integrated with IoT, then okay, energy production will also be increases. Okay, there are other additional contributions IoT in energy management, predictive maintenance. Okay, which monitors equipment health and predict the failure, reduces downtime and prevents energy wastage. And if we integrate with the AI, which will be used to analyze IoT data for energy forecasting as well as the optimization. And another is scalability. IoT systems can scale from homes to cities, which are used to enable efficient energy management. Another is environmental impact, which are used to reduce carbon emissions by optimizing the energy usage. And these are the future trends in IoT for energy management, how the other technologies have been integrated for the energy management. That is, one is blockchain. Okay. And another is IoT powered with 5G technology, IoT security, traffic management, IoT empowered AI applications, digital twin, smart cities, metaverse, voice activated IoT devices, and edge computing. There is a huge demand, huge research is going on how these trending technologies have been integrated to IoT for efficient energy management, starting from the blockchain to edge computing. Now, another portion of our energy management is artificial intelligence. As of now, we discussed about how this IoT is useful for energy management. What are the components of IoT, right? And what is the architecture of IoT? What are the applications of IoT? How this IoT is going to use for the energy management. And another portion of the topic is how the artificial intelligence is going to be used with the energy management. The name itself indicate artificial intelligence, nothing but a simulation of human intelligence in machines which are programmed to think, reason, learn, and make decision like a human being. In a simpler words, artificial intelligence means we are going to simulate the machines which behave like a human being. The key features of AI are which mimic like human being, which adapts to new inputs, and which execute the task typically where human being are okay doing. So that is called artificial intelligence. Nothing but you are going to make a system to think and act like a human being. What is the importance of AI? Why people are discussing about AI? Why everybody is saying AI, ML, AI, ML? Okay, enhances efficiency and productivity. The best example is if you can see, okay, Chat GPT. People used to use the Chat GPT for grammar verification, correction, okay, sentence formation, everything. Automates repetitive task, which improves decision making process, which drives innovation across the industries. The applications of AI in various fields like healthcare will be used for the AI diagnostics or robotic surgeries, self-driving cars, and also fraud detection. These are the various applications of AI. Generally, unlike IoT, there are various components of AI also: machine learning, NLP, natural language processing, computer vision, robotics, and expert system. First one is machine learning, which allows systems to learn and input from the data. Machine learning, machine will learn from the data without any explicit programming. And second is natural language processing. It is going to process the language, which enables machine to understand and respond to human language. Okay, best example is like Amazon, okay, Echo. If you ask Amazon Echo to sing a song, okay, it will understand your language, right, which you spoken in English, and that will be given to you the app, and automatically corresponding song will be played. Natural language processing. And another is computer vision, which helps the machines interpret, analyze visual data, visual data, which is used to analyze the visual data. Robotics, okay, integration of artificial intelligence in machines to perform physical tasks. If you take an example, Amazon warehouses, once you, okay, book any item through the Amazon, it will be, okay, given to the Amazon server. So there are lakhs of uh, items will be there in the Amazon warehouse. So how they are going to handle? They are going to handle small robots. Once you book any item through the Amazon, it will be given to the server, so that the task will be given to the small robots. Small robots will go into the Amazon warehouse. It will read the barcode of the item. Okay, it will scan, it will take, and it will, okay, pack. So this is the one of the beautiful application of integrating AI with the machines. And then the expert system, which mimic human decision making through rule based system. These are the various components of AI. And another is there are different types of AI: narrow artificial intelligence, general artificial intelligence, and super artificial intelligence. Super intelligent AI, super artificial intelligence, will surpass the human intelligence. Like you might have seen the, okay, the Robo movie of Rajinikanth. The last, okay, that Robo will surpass the Rajinikanth, because it possesses the super intelligence. So that will that's why it will not listen the instructions of the his boss, and it behaves okay on his own, and it surpasses the human intelligence. But as of now, we're still in the research stage. And then the general AI, which perform okay, any task where a human can do. And another is narrow tasks, like a simple, okay, the game development, like it may be okay, chess game, or it may be some small kind of okay, task which uses artificial intelligence. When it comes to the AI, what are the challenges we are going to face? Ethical concern, privacy and bias, right? We have seen in the Robo movie, right? It is completely surpasses his boss, and it acts as okay, boss, right? So then obviously, okay, there is a question about ethical concern. And then there is data quality and availability. If you want to build a artificial intelligence enabled system, so obviously, okay, it will take a huge cost, high computational cost, and a lack of transparency. Okay, you are going to write, okay, and you are going to build the system, but where is the questionable? Okay, where is the ethics in that one? So that is called a lack of transparency, or black box AI, or ethics in AI. What are the futures of AI? So edge AI and real-time processing they are going to use. It is going to AI is going to use in healthcare as well as other sectors, and AI is going to transform the workplaces, as we are going to see entire thing. Everybody is speaking about AI, machine learning. Okay, and it is going to work in collaboratively with the human being. No, this is the fundamentals of artificial intelligence. Artificial intelligence, nothing but we have to simulate a machine which works, thinks, act like a human being. It's not nothing but you are going to write programs. Okay, so that the programs, how you are going to integrate with the IoT for energy management. So the role of AI in energy, the management, predictive analytics for energy consumption, optimization of energy usage through machine learning models, fault detection and maintenance energy system, and AI algorithm for load forecasting. Okay, AI in energy management. Let us take what actually the energy management is. Energy management involves monitoring, controlling, and optimizing the generation, distribution, transmission, and consumption of energy. That is called energy management. When the power supply is generated, you need to monitor the power supply, control, optimize, distribute, transmit, and consumption. Okay, why it is matters? Why? Because okay, why we need to so too much bother about energy management? We have to make sure that efficient energy will be supplied to the consumers, and at the same time we have to make sure that it has to reduce the environmental impact. Too much of coal nowadays. Okay, the governments are coming with the open cast mines, which will okay uh, pollute, and there are lakhs of trees has to be burned for this one the open cast mining. Okay, obviously it will impact the environmental. So if we use the okay the different technologies, so obviously you can reduce, and which lowers the operational cost. Role of AI in energy management: energy forecasting, predicts energy demand and supply using historical data. Machine learning algorithms will be used to predict the energy demand. Like if you have in the 4 areas, 1, 2, 3, phase 1, 2, 3, 4, you can identify, or you can come with a solution saying that okay, based on the historical data, okay, this line or this phase, okay, there are chances that this phase will use high energy. That is, predict the energy demand and supply based on historical data. Like they will take the 1 month, 2 months, or 3 months data, and they will apply some kind of machine learning algorithms, and they will say that this is the energy demand, and enables better grid management. And another application is smart grids, which will use for automate grid control and optimization. Okay, and it also be used for balancing the supply and demand. And the third one is integrating the renewable energy, manages the variability in renewable energy, because the power, the quality of power in solar, wind, as well as the power generated from the water as well as the coal is different. So how it is going to manage the variability? So if it is integrated, okay, if you are going to use the technology, then you can manage the variability in renewable energy sources. And it also used to enhance the storage and distribution efficiency. And it can also be used to optimize energy uses in building as well as the industries. So what are the benefits of AI in energy management? The key benefits: cost saving, which reduces energy cost. Now every government is thinking how to reduce the cost. That's why they are asking the people to go with the solar as well as the wind. Sustainability, okay, promote the use of clean and green energy. And reliable, which enhances the grid stability and reduces the okay power supply fluctuations. Scalability, okay, if we optimize the power supply, then obviously okay the scalability means you can satisfy the growing energy demand. The various AI tools and technologies which are used in the energy management: machine learning models, which are used to predict energy trends; IoT sensors, which are integrated with AI, will be used to collect real-time energy data; digital twins, simulate energy system for optimization; and energy management system, which will be integrated with the AI for monitoring and controlling. What are the challenges of implementing? Yes, okay. At one point in time, we are saying if you integrate the AI, okay, you can reduce the energy cost. You can go for the optimization. You can identify. You can also predict the energy demand. But what is the challenge in implementing artificial intelligence energy management? The very first challenge is high initial cost for AI development, right? Maintaining the large power grids, which the power grids, let us assume, power grids are used to monitor the power supply for entire Hyderabad. So how the AI systems have been used, okay, to monitor the or to optimize the energy management. So high initial cost for AI deployment, data quality and security concern. When you are saying smart grid, which is integrated with AI and IoT, then obviously, okay, security concern will be there. And if you are using the agile infrastructure, the old infrastructure, okay, you will face another challenge called resistance to adapting the new technologies, right? You cannot integrate or you cannot convert the old or agile infrastructure to IoT as well as the AI. And the last is key challenge is you need skilled professionals who are familiar with IoT as well as the AI in order to make sure that your smart grids will work efficiently. What is the future of AI in energy management? Emerging trends: decentralized energy system using blockchain and AI, and many governments, many organizations are using this word called net zero energy goal, net zero. Okay, you have to make sure that the energy consumption generation will be okay, like minimized. We need to make sure that the resources have been used effectively, and global adoption of AI driven energy solutions. AI plays a vital role in modernizing energy management. Despite various challenges, AI has the potential to revolutionize the energy sector. As 100 years back, right, the power, the electricity, we'll call electricity, has transformed the entire world. 100 years back, the electricity has transformed the entire world. We cannot imagine, okay, we cannot imagine without power supply. Even we cannot bear for 5 minutes power cut also. Similarly, we can say AI is a new electricity. Without artificial intelligence, no, okay, the organization, no industry, or no, okay, any one is going to be run. So we are calling it as AI is a new electricity. And we need to identify AI driven energy solutions to optimize energy needs. Applications in renewable energy, how it is going to use AI and IoT in solar and wind energy optimization. It is going to use to forecast the renewable energy generation, because unlike okay, the power generated from the coal and the water, the renewable energy generation, okay, is very difficult, and okay, we cannot forecast also. So we need to manage this energy storage and distribution. And these are the benefits of AI and IoT in energy management, which is used for improved energy efficiency, cost reduction, enhanced sustainability, and reduced carbon footprint, and also proactive maintenance and reduced downtime. We can reduce the, okay, downtime of the power supply. Okay, improved energy efficiency. AI will optimize energy consumption by analyzing the data. IoT sensors will be used to monitor real-time energy uses. Like the example is okay, smart thermostats, automated lighting system, cost reduction. AI predicts and reduces unnecessary energy usage. Thereby, we can reduce the cost. IoT ensures operational efficiency through monitoring, and it will be used to reduce the operational and maintenance cost. And third application is enhanced sustainability and reduced carbon footprint. AI will help integrate renewable energy sources like solar and wind. IoT will track the carbon emission, how much carbon is okay, and it will make sure that okay, it will be compliance with the sustainable energy goals, which in turn, okay, if we can adapt the IoT and machine learning or AI, we can support the global environmental sustainable development goals. And if we can integrate AI and IoT, we can proactive maintenance and reduce downtime. AI predicts the equipment failure before the okay. This is called fault tolerant systems. We can identify a machine, okay, whether the machine is properly working or not, when the machine is going to okay down. So AI will predict the equipment okay failures. IoT will be used for a real-time alert system for system health. Okay, thereby they will be used to minimize the disruption and increases the system reliability. What are the challenges and limitations? You are saying you integrate IoT components, sensors, you integrate with the artificial intelligence. You are saying that you need to manage the data, okay, which is generated from the grids. But what are the challenges and the limitations? Data privacy and security concern, high initial implementation cost, and we also face technical challenges in integration because the power generated, as I mentioned, power generated from the solar wind is different from the other source of one. You will face technical challenges in integration, and also you will face a lot of challenges okay when you want to make your agile infrastructure into smart one. You will also face various challenges if you install the smart meters. There is various technical challenges, and another is we need skilled workforce. Okay, if the people who don't know what is IoT, what is artificial intelligence, okay, he cannot build, he cannot work on the okay smart energy systems, smart grids. That is also another challenge and also another limitation. What are the future trends in AI and IoT? Integration with smart grids and blockchain. We also mentioned we need to build autonomous energy platforms. Whenever you are going to use AI, you need to predict there is a demand for the power supply, and we need to make sure that the 5G or it may be 6G has to be integrated with the IoT. These are the various use cases which are adapted from the various literature. You can okay observe left hand side there is a various power supply, like it may be solar, it may be wind, it may be biomass, it may be tidal waves. The power supply will be given to the grids as well as the storage. Okay, the green line will indicate just a control flow, but the black one, the black marked one, it will indicate the electric flow. Okay, and the power will be given to grid. Okay, and okay, various if you can observe in the green one, IoT as well as the AI has been okay integrated with this one. They can easily monitor the demand for the residential sector, demand for the industrial sector. Okay, this technology will help us to identify the faulty systems, and they can also use in maintaining the smart meters. This is also one use case, and another use case. Okay, you can see the smart home, right? Mobile application will have the internet. You will have the various applications. In the extreme right hand, you can find a smart grid where the power is given to the smart meters. From there, power supply will be used for various applications. It may be okay like a critical load, as well as the power in our home. It is like a smart home system which is integrated with AI as well as the IoT. Power supply is drawn from the smart grid, which is shown in the extreme right and top, which the power supply will be recorded through smart meters, and power supply will be given to the household purpose, where which is integrated with, you can see also the internet, where router is installed, which is used to analyze and control the units. And the various the power will be used for various purpose. It may be flexible load, or it may be we can also see the UV, and which are used for critical loads. From there, you can easily monitor for where or which machine consumes which power supply. So this is also one application, smart home system. And another is same how big data and AI will be integrated with the power system. Extreme left, you can see solar power, wind, geothermal power, hydropower. Where the power supply will be given to the transmission lines, and the right side you can see demand side management and energy demand forecasting. Home, the power will be given to home, but where in between you can see the power grid control center, where the they are going to optimize the energy, where they are going to monitor the power supply. And last one, what are the recommendations and best practices for this one? We need to adopt various strategies for AI and IoT, which is to be used in energy system. We have to make sure that there should be some collaboration and cooperation between the various stakeholders, public and private. And we have to make sure that we need to come with stringent policies where we can follow these smart and sustainable development goals. And finally, come to the conclusion of this presentation. AI is widely used practically for all renewable studies, for planning, construction, administration, prediction, regulation, and transmission of energy. It is the need of the hour to develop AI and IoT enabled devices, and also AI and IoT software packages, which are used to recognize the efficiency of the electricity, and also better investment for individual in the upcoming years. The connection and optimization of renewable energy with electricity networks used for the utilization of AI technology, which can be used to improve flexibility, dependability. And obviously, if we can use the AI as well as the IoT, then the companies will also get profitable. And in turn, AI has the potential to change numerous power industries, and which will be used to boost the development in the next years. As I mentioned, the 100 years back, electricity had changed the entire world. Now, this new AI is going to change the entire world. So that's why we can say AI is the new electricity. Integrating AI, IoT with the energy management will obviously help for efficient energy management, which will help for sustainable development to achieve the sustainable development goal. For this, we need to work to build the efficient AI and IoT systems, which will help for efficient uses of this energy management. So with this, I'll stop my presentation. If anybody having the doubt or questions, you can ask me.
Thank you, sir. Thank you, Zabbar, sir, for sharing your knowledge with us. Thank you. Thank you, all participant.
Good evening, sir. This is Dr. Shamshad Begum from Manu University.
Yeah, madam.
It was very nice hearing from you. You have dealt in detail uh, AI, and we have so many we use it, but we hear so many things about AI in the far Western countries. If we use it excessively, a time may come when machines will have control over human beings. They say, like just now you have explained about power grid failure. So very skilled person must be. But God has made human beings. I am a biological enthusiast, biological science, environment enthusiast, and I thought this topic was very nice, and I'm very thankful to Polytechnic department for engaging such a what you say resourceful resource persons. So in the meantime, like in the future, like humans have to, I feel it, they have to make use of artificial intelligence till they require it for the purpose of usage. But when even skilled persons get tired after certain time, so that neuro psychology, what you say, that has to be dealt with, because machines do not have emotions. Human beings have emotions, and human beings have a feeling of tiredness. Human beings have the feeling of responsibility. Oh, one can't bind to their work hours, must be limited, and when the work hours are there, that work must be given. Therefore, sometimes it so happens young professionals, for the sake of earning, they work for long hours. I have heard certain very drastic fatal cases in our far friendship groups, where the children have really, I just don't like to discuss that, and there are no more like that. So this they were highly paid, but of what use is that when they are not there in this world? So like that also I have heard certain 2 3 cases, who work in the US and all. Of course, everything is useful, everything has its pros and cons. We must use it legibly in time limits and workability. Even skilled persons are not, they must not become slaves to machines. That is what I keep telling. I think if I'm wrong, you have given us updated the knowledge of artificial intelligence, and they are saying this year is named as a year of artificial intelligence, I think, if I'm not wrong. But there is for us no other way, that we have to learn about it. But machines, once given commands, they can't have that emotions of thinking, can we do this, can we do that? So that leads to that, what you're telling, that
Yeah,
power
yeah, madam.
grid failure.
Exactly.
So that is that thing that pinches me. So I feel really, I being a biologist, see, if we have that love and emotion, if a person gets angry, after a certain time they understand, they realize, then that meditation or something, and they'll come back to some counseling, or they console each other. But machines, one taken command, they can't do that. So even those people who are skilled, they too need some rest, some gaps. That all thing must be there. So that planned way of people who make that arrangement of that organized work, that must be very well set. I
Yeah,
think,
madam.
if I'm not
Actually,
wrong.
if you can observe, at the long back, they came with the driverless car. Now you can hardly find the driverless car. And
Yes, yes.
yeah, why? Because they programmed the machine in a way such that it has to drive. Okay, but it cannot understand the complete environment. So there are some kind of accident happened.
Yes,
Immediately
sir.
they stopped
Yes.
the project. And
Yes, sir.
another
Yes.
the project similarly is like face recognition system in some
Hmm.
countries. Okay, in especially in the airports, they used to have the face recognition, or in even offices also. So what happened, once it identifies the face, it is going to, okay, differentiate with the based on the color and gesture of the people. So it completely goes into a different way. Okay, let us take if African countries and US, then the system is to, okay, differentiating, you are from this okay region, and you are from this region, you are, okay, belongs to this color. So immediately they also stopped. So obviously there is some kind of limit to use these
Yes, sir. Yes, sir.
technologies. Yes, obviously.
Thank you so much, sir. Thank you so much. There must be a
Thank you.
collaborative work between biologists and this
Yes, obviously. Yes.
computer-enabled person where they can. And that I'll tell you, see, in our far relatives, also even near relatives, some people are there who work, who have worked for more than 15 to 20 years for this, what is say, computers in this. Era for, and these though they are the people or with young age, in a young age they have so many diseases, sir. We feel so sorry, they have earned so much but they're not able to enjoy the basic things of type of food what they want to eat. Even such things are there. So they have their body becomes so differently enabled that they'll not be able to do unless and their nerves do not work properly, their liver does not work properly. So many, what you say, that static type of life what they have led to earn, because in between there was so much of IT boom from 2000 to the about 15 20 or something. Now slowly again so many other courses also have come up and all, in that they are utilizing. But this all matters need to be higher administrative people and thinkers and philosophers and educated people like you and all must just plan certain
Yes.
things
Yes.
and
Yeah.
must come out with certain what you say, resourceable topics and all, that which enables young people to manage themselves also. Of course there's so many meditation nowadays, this that, but in the race of earning money and in the race of getting too much in too less time, they're spoiling their health and all. And now of course that machine work what I have heard, I told you know, in far families, in some
Yes. Yes, madam.
families
Yeah, I
it
think
has
one uh, participant asked uh, the elaborate the blockchain technology in the interest of time. The actually blockchain is a distributor digital ledger uh,
Mhm.
for securing transparent and tamper-proof data. Generally, if you go to banks, will have the ledgers. So
Mm.
similarly, this blockchain is also distributed digital ledger. Okay, which the people claim that is a tamper-proof. If something happened, it is like a chain system. If something happened, okay, immediately they can also identify, can also trace this one. That's why now people started integrating this IoT as well as the AI with the blockchain technology. There are various the applications of blockchain technology. I think you might hear the cryptocurrency like
Ah, yeah.
Bitcoin, Ethereum, and also okay secure transactions. These also used like in the surveys also, even land survey for also they are going to use, and they are going to use for healthcare also to secure the medical records. Generally
Mhm.
hospitals will store the medical records. So if you go to medical hospital, okay, and if you talk with them, generally what the hospitals will do, they will give the data. So generally if the data is stored for especially for healthcare data, why? Because everybody concerned about their personal data. If the data is okay stolen by somebody, and they may blackmail you, okay, saying that you are having this disease and this you are okay having this DNA, this kind of things happen. So for that one, in order to safeguard the medical records also, okay, people are started using the blockchain technology. So similarly, this blockchain will also be used to integrate with the IoT. Whenever we need to remember, whenever you are integrating these devices, any device to internet, there is a possibility of threat, including the artificial intelligence. But in turn, we have to use the limited. We have to learn. We have to use the technology, but okay, we have to make sure that where it has to be used and where it has not to be used. Then,
Yes, yes,
then
sir.
only.
Right. You're right.
Yes.
Mm.
Right. Thank you, madam.
Thank you so much. Thank you so much.
Thank you, Jabbar sir. I hope all the queries of the participants have been answered. So we'll end the session now. And the
Yeah. Thank you,
participants are
madam.
requested. Thank you, Jabbar sir. Thanks a lot for
Right,
a very
madam.
informative session. I request the participants to fill up the attendance come feedback form, which is being shared in the chat. Then you can leave them. Thank you, one and all.